Silver-plated speaker cables are marketed as the upgrade your system needs. Better conductivity, cleaner highs, the kind of cable the professionals use. What nobody tells you is that silver and copper in direct contact, in the presence of air moisture, create a galvanic cell, and over months and years, the copper core beneath that shiny plating quietly turns to powder. So before you spend another dollar on cables, can you tell me the last time you actually pulled a connector and looked at what was inside? 3 years ago, I pulled mine. I had a pair of silver-plated cables I had bought for just under $200. Nice-looking things, braided sheath, heavy connectors, the kind of weight that feels expensive in your hand. I had been using them for a while and the system sounded fine, I thought, good even. But something was off in the top end. Not wrong exactly, more like a graininess that had crept in. The kind of thing where you turn the volume up a little looking for detail and the detail still isn't there. I figured it was the recording. Then I figured it was my amp needing a service. Then, one afternoon, I pulled the banana plug out of the back of the speaker terminal and turned it over. There was a reddish-brown powder in the housing. Not dirt, not the green you expect from bare copper in a damp room. A dry, crumbling residue the color of old brick dust. I put it on my fingertip and rubbed it. It disappeared into nothing. That powder was copper. The core of my cable was dissolving under the silver plating I had paid good money for. I had been listening to a degrading signal path for months and blaming everything except the cable. The graininess was not in the recording. It was not in my amplifier. It was in a connection 2 centimeters from my speaker terminal, where the silver and the copper were eating each other alive. Every time I turned the volume up to find the detail that used to be there, I was pushing more current through a corroded joint. The detail was not gone. It was being filtered before it ever reached the driver. That is where most people are right now. Their system sounds okay, maybe a little flat, maybe the highs used to sparkle a bit more, and now they just sort of arrive. They have been to a dealer, maybe bought a new interconnect, maybe swapped a DAC, or replaced a cartridge. The speaker cable stays, because they were told that cable was an upgrade, because it cost money and felt substantial and had silver in the name. The cable was not an upgrade. It was a slow failure they paid a premium to install. The reason this happens, the chemistry behind it, is something NASA documented in depth in 1965. The cable companies have never found it particularly useful to mention. Quick word before I go further. The old methods my family uses, there is more of it than fits in any one video. I gathered the whole of it into a book you can buy in our pinned comment below. The book is the long version. If you want it, it is there. I will not mention it again. So what is actually happening inside a silver-plated cable, and why does it damage your sound? Start with the number the industry leads with. Silver is a better conductor than copper. That is technically true. The resistivity of silver is 1.59 micro-ohm centimeters. Copper sits at 1.72, a 6% difference. That is the entire argument. 6% lower resistance, silver passes the signal more freely, the highs come through cleaner, the system opens up. It is a clean story, and it would be a good one if that 6% made any audible difference in a 2 to 4 meter speaker cable run carrying audio signals between 20 Hz and 20,000 Hz. It does not. Not in any measurement taken by any independent researcher in any controlled environment. Not double-blind, not single-blind, not even in a room full of people who believe it matters and are told nothing about what they are hearing. The gap between 1.59 and 1.72 micro-ohm centimeters at the power levels running through a domestic speaker cable is below the threshold of detection by your ears, your instruments, and anything except the invoice. Meanwhile, the cable is corroding. Here is the chemistry. 2 metals in contact, silver and copper. They sit at different positions on the galvanic series, which is the ranking of metals by electrochemical reactivity. Silver is more noble. Copper is less noble. In the presence of moisture, any moisture at all, humidity in your room, the oils your hands left on the wire when you installed it, condensation on a cold morning, a galvanic cell forms at every point where the silver plating has a microscopic pinhole, a scratch, or a nick from handling, a tiny battery. The silver plays the role of cathode, the copper plays the role of anode. The anode always corrodes. That is not a design flaw. That is electrochemistry working exactly as it should. The copper core of your cable is actively sacrificing itself to protect the silver surface around it. The corrosion product is cuprous oxide. Red-brown, sometimes dark brown, sometimes appearing as a powdery residue at the termination where moisture collects inside the plug housing. Engineers in aerospace and military wiring have been documenting this failure mode for over 60 years. They call it red plague. The ESA, the European Space Agency, has a dedicated specification document on corrosion in silver-plated conductors. NASA studied it and put a 10-year storage shelf life on silver-plated wiring even when manufactured to aerospace tolerances and stored in controlled humidity. Your cables are not manufactured to aerospace tolerances. Your listening room is not a controlled humidity environment, and nobody told you there was a shelf life on the cable you bought to improve your system. Now here is what makes the main technical claim used to sell silver cable: the skin effect argument. Useless in this context. The skin effect is real physics. At high frequencies, alternating current does concentrate toward the outer surface of a conductor. Higher frequency, thinner surface layer carrying most of the current. Silver on the surface means better conductivity exactly where the signal runs. Logical, except for one number. The skin depth in copper at 20 kHz, which is the absolute ceiling of human hearing and a frequency most adults over 35 cannot meaningfully detect, is approximately 0.46 millimeters. The silver plating on consumer cables is typically between 0.1 and 0.3 microns thick. 1 micron is 1/1,000,000th of a meter. The plating is roughly 1,500 times thinner than the depth at which skin effect operates at audio frequencies. The engineering context where the skin effect argument is valid starts at frequencies above 3 megahertz, 3 million hertz. Your music tops out at 20,000. The skin effect claim belongs to radar equipment and radio transmitters. It was borrowed from a valid engineering problem and pasted onto a product where the physics does not transfer. That is the trick. A real fact moved to a place where the fact no longer applies by people who knew exactly what they were doing. So here is what you actually do. 4 steps, under $60 total, starting this weekend. The first step I call the inspection. Pull every connector from the back of your amplifier and the back of each speaker. Turn each plug over under a good light. You are looking for red-brown or dark brown powder at the point where the bare wire strands enter the housing, or any discoloration that is not the bright copper color you would see on fresh stripped wire. Green means standard oxidation from bare copper exposed to air, a different problem. Red-brown means red plague. That cable is compromised, and the longer it stays in, the more of the conductor you lose. The corrosion moves from the termination inward along the strands. If you catch it early, cut an inch past the discoloration, strip the cable fresh, re-terminate. If it has been running for 2 or 3 years in a humid room, cut 2 inches to be safe. The body of the cable is usually clean. It is the termination point, where moisture enters the housing and sits against the metal, where the reaction concentrates. The second step is what you replace it with. Canare 4 S11. That is the cable. Star quad design, 4 conductors wired in parallel pairs, 1 pair per polarity. The geometry reduces inductance and rejects interference better than standard 2-conductor cable. It is used in professional recording studios, broadcast facilities, and live sound installations where cables are abused daily and need to work without interruption. It costs around 60 to 70 cents per foot depending on where you buy it. A 3-meter pair of speaker cables uses roughly 20 feet of wire. That is $12 to $15 in cable. If you cannot source Canare, Mogami makes the 3082, similar specification, similar price, similarly plain in its presentation, similarly reliable over time. Neither of these cables is exciting. There is no braid. Nothing signals luxury. They just carry the signal cleanly for as long as you want to use them. That is the job. That is what the job is. The third step is termination. Get locking banana plugs, the type where a barrel turns to expand the plug tip inside the socket for positive mechanical contact. $2 to $3 per plug. 8 plugs for a stereo pair, so $20 to $24. Get nickel-plated plugs, not gold. Gold is softer than nickel and wears at the contact surface faster. The conductivity difference between gold and nickel at audio frequencies is not detectable by your system or your ears. Nickel is harder, more durable, and perfectly appropriate. Strip 8 millimeters of insulation from each wire end. Twist the strands clockwise so they hold together. Insert into the barrel until flush. Tighten the housing. That is a terminated cable. Total material cost for a terminated 3-meter stereo pair, wire and plugs combined, is under $40. The fourth step is the one that makes everything last. 1 bottle of DeoxIT D5 made by Kaig Laboratories, about $15 at any electronic supplier. Once a year, which is the entire maintenance schedule, you pull each connection, apply 1 small drop of D5 to the contact surface, reconnect. DeoxIT displaces moisture and leaves a thin protective film that prevents oxidation forming on the copper surface without insulating the connection. The layer is thin enough that metal-to-metal contact is maintained fully. This is what broadcast engineers use on patch bay connectors and equipment terminals that have to run without failure for years at a time. 1 drop per connector, 8 connectors for a stereo pair, once a year. The whole process takes under 3 minutes. That is your complete cable maintenance plan for the next decade. Here is the bigger picture, and I think you are owed it. The cable industry runs on a transfer of meaning that has nothing to do with audio engineering. Silver means quality. That association was built over centuries in silverware, coins, jewelry, and surgical instruments. It transferred into audio cable marketing without any of the physical justification that made it meaningful in those other contexts. When you buy silver-plated speaker cable, you are not buying a measurably better conductor. You are buying a cultural association and a 6% resistivity advantage your system cannot detect, wrapped around a corrosion mechanism that will quietly degrade your signal over the months and years you use it. The premium for silver plating over plain OFC copper at equivalent gauge and construction can be 300% or more. That money goes to the braid, the marketing, and the 4 letters of the word silver, not into the signal. The hard-won truth from anyone who has pulled enough connectors is this: the most expensive part of a bad cable is not the cable. It is the months of listening to a degraded system and adjusting your expectations downward without knowing why. Turning the volume up a little, deciding the highs are just a bit soft now, living with a system that used to be better and you are not sure when or why it changed. Here is what I want you to do tonight. Pull 1 connector. 1. Look at the wire inside the housing. If it is clean and bright, your cables are fine and you can move on knowing that. If you see any red-brown powder, any discoloration in those copper strands, you are looking at red plague and you now know exactly what it is and exactly what to do. A terminated Canare 4S11 pair and a bottle of DeoxIT D5 is under $60. That is the whole fix. Tell me in the comments what you found when you pulled that connector. Clean, corroded, or something in between. I read every comment and I will reply to anything that tells me what you found. I want to know how widespread this is. Next time, I am going to show you something almost nobody in audio discusses: why the orientation of your speaker binding posts, whether they face straight back or angle downward, changes the rate at which moisture accumulates inside the terminal, and what that means for how often you should be cleaning them regardless of what cable you are using. One small choice the speaker manufacturer made for cosmetic reasons is making your maintenance problem worse than it needs to be. Until then, pull that connector. What you find might change how you think about every cable in your system.